Hello everyone. Today I'm going to explain about the threads concept. So in Java, the thread is very important because without threads there is no Java program running it at all. So the thread means that it's a smallest section of a program in the entire Java. It's a small thread. A Java program can contain more than one threads, like either one or more threads running at the same time. So basically you can achieve the parallel execution of your subsections using threads. What we will get out of these threads, because if you want to use the threads will use your CPUs and your memory to the extent where it can be used, so that way you can execute the your application in a shorter time. Yeah, how to create a thread in Java? So there are basically two ways in creating threads in Java. One is by extending the thread class, and one is by implementing a runnable interface. Yeah. So there is another way as well. You can use the executor service to create the threads. That will come in the later section of the parts. By first thing, by extending the thread class. So this is very simple way of creating the thread, because you just have to extend the thread class. The thread class is available in java.lang.package, and override the run method. Let's see how you can create a thread in Java basically. So now I have a couple of classes here. We'll come to the later part of this section of this tutorial. So the first thing, it's a first thread. We will have a main method, which I will explain. Main method is also one thread basically. By default, it's one main thread will be there. And how you create a thread, a custom thread basically, the user thread. So just create a class and extend the thread class. Thread class is part of the java.lang package, and then override a run method. So now we have only simple statement in the run method, which is a thread running. And how do you call this? How do you start the thread basically? Of course, how do you run the thread? So in the main method, we will just create a thread. How do you create the thread? Is it's in the status of new now here, because you just created a thread. You did not run or you did not start the thread. So then can we how do you start the thread? So thread dot start. So this means that this thread is in a runnable state based on availability of your CPU and the memory. That thread scheduler will schedule this thread to run it. Once the thread scheduler will run this, so then this piece of code in the run method will be executed. Yeah. So we will start running the thread. So this is my first class, and we'll start the thread. Yeah, you see that the thread is running. So the thread is started, and then it has ran, and then the program has been finished. How do you know that the thread has ran exactly? So basically in Java, that main is also one thread. How do you know that the main is also thread? So we have uh, a, a static method in the thread class to know that what is the current thread running actually. So if you want to see that, like, we will just print out a statement in the main method that's saying that the current thread name, current thread is just thread dot current thread dot get name of it. So the same statement we will be executing in the child thread, right? We will try to put it in the before the thread running, because that we will come to know easily that, right? Yep. So then we will re-execute the same class. Yeah. So the current thread is thread 0, and thread is running, and the current thread is main. So after the start, so immediately it got executed because the thread scheduler is available. How do you see that this? Because suppose it's not a sequential. So now you see that, hey, it's like started and then the current thread and thread is running the printed and the current thread is main. So it is a sequential for you. But the threads will not run in a sequential. The threads can run on based on the thread scheduler. We cannot guarantee the program. We cannot guarantee the running of the threads in a sequential manner. So how do you say that this? I mean, if the if if the child thread is taking time, the main thread will finish in the time. So suppose that we will just intentionally keep some wait time in the thread so that it will take time to execute the section. So this will automatically, it's a checked exception, interrupted exception is a checked exception. So it will throw in between any exception, so we have to catch it, right? And then we will print an exception saying that a thread got interrupted, right, for now. Yep. So this is fine. Now let's execute the same thread and then see. We cannot guarantee the order of the execution of the thread. So now, because it will wait, right, in the time that main method will be finished. So the main method will be finished and the current thread and the thread is running. So upon after all the threads finishes, your program will be exited, right? So this is the basics of the thread. Then the second thing, so how do you implement the second way of creating a thread, by implementing a runnable interface. So the runnable interface is a functional interface which has only one abstract method, which is called run method, and you have to implement that method. So in the thread class you have to override it. Now we have to implement the run method. How do you call the interface again? So but though we have a runnable interface, we have to have a thread class to initiate the call the runnable interface, right? And why this is, we will call the runnable interface as the most recommended way of creating the thread. Why? Because since if you extend a class thread, you cannot extend anymore. You cannot further implement. You can implement the interfaces, but you cannot extend it. You have to do only the thread related jobs only when you create an object. So but if you implement a runnable interface, that apart from the thread functionality, you can use it for any other purpose as well. For an example, you can extend the comparator as well. Implement the comparator as well, so that it compares the same object, right? Let's see the example how do you create a threads via runnable interface, right? I'll be going to the same section of the code and all. So let me close all of these things for our purpose. Then we have the same thing, a main class which is a runnable thread, and how you create as a my runnable class, and which implements the runnable interface, and this is an implementation of a run method, the same thing. But what is the difference here is this one. So thread, new thread, and my runnable, right? And the same way of creating, starting the threads on. So if we execute this as well, it will be the same. Like, let me execute this, the runnable thread class. So in this one, so basically we have to pass an interface, which the class which implementing the runnable interface to an object here, right? So the thread is running now. So you might wonder that how do you manage the threads if we have a more, right? So threads you can identify with the name of the thread as well. So by default, so previously, like I'll just go back to the first thread class, and we have, if you see this program, if I execute, right, because we can get the name of this thread here, right? Current thread dot get name. Sorry, it's a first thread. Yeah. So if you see that the current thread is main, and the current thread is thread -0. This is the name of the thread. Can we change the name of this thread? Yes, of course we can change it. So you have to pass the information, like the name of the thread. So we will say it is a child, right? And then for an example, we don't have a constructor here. Of course we have to create a constructor, and call the super, I mean the thread, uh, basically its name, I mean the thread class of the constructor, we have to super of name. So this will get created a name of it. So now if you execute it, so the current thread will be there, it will be changed to the name of the thread what we have given a custom name here, right? So the current thread is now child here, right, this way. Now, so since this is a main thread, so main thread is the one which is a default thread which will run when you run the program, the main program. Can we change the name of the main thread as well? Of course, yes. How do you? So because we don't have a, we are not creating that, right? So we can change it by using the same thread dot current thread dot set name. We will say that it's a customized name, right? So I'm just re-executing the same name after giving the name for the main. So if you see here, the custom current thread is customized name and the child, and we have an example for the same thing as well here, which is the thread name class child thread and everything. So we have all those, like you can set the name of the, the child thread and all everything, right? So this is how it's, you can change the name of the thread. Next section in this part. So the other thing is the life cycle of a thread. So for every thread, um, from the creation to the terminated, there will be different states or states of the thread we will be having. So the first thing is a new. So the thread is created, but you did not start the thread. So that means it's a new. So in our case, that creating an object for a thread is a thread. It's in a new state. And then once you start it, it will go into a runnable mode. Runnable and running both have the runnable state only actually here. Okay. So again, once you start the thread scheduler is responsible to the run the program of the thread. So it will be in a runnable state, both runnable and in a running, while running as well. I mean ready to run and running. So then it's a blocked. So a thread is waiting for a resource that is logged by another thread. So that means that you are waiting for a something and you are blocked about it. For an example, if you wanted to travel somewhere, right, a bus, you need a bus to travel, for an example. So if the bus didn't come, you are blocked. I mean you were still waiting for that the bus thread to come here, and once the bus comes, then you will be unblocked, and then you are running state, and once you reach your destination, it's you are in terminated state. I mean blocked, that is. So waiting also is something like that only. It's like waiting. So then the timed waiting. Blocked is something which is different than waiting, but it will come into the later part of the section. So the timed waiting is nothing but like you will wait for certain time and then you choose another option, right? And once you finish it, it's a terminated basically. Got it. So these are the states of it. So then we will check how the thread states will be there in using a practical example here. So then we have a life cycle thread, right? So then I'll explain clearly. So now we have created a thread with which names child thread in the main section, and we are getting the name of the state. So the child thread dot get state dot name. So that means that you are getting the name. I mean you are getting the state of the thread. What is it? So here it will be new. So once you start, then you will be started it actually. We'll start the execution. I'll explain this part later. So then the child thread, we will get the state after that. All of these things, like again the main thread state, the main thread name also we will get it. So then once you start the thread, it will run, and then once you join the thread, so joining the thread is nothing but like the main thread will wait to finish the thread child thread and then move on. For an example, let's say that you don't have this section, right? The sequence of execution would be, so like you will start the thread and the thread will wait for 3000 milliseconds. Let make even 1000 milliseconds for now, no issues there. So 1000 milliseconds, and the meaning of wait time, the main thread will finish its execution, and it will the entire like the Java program will wait to complete all of its thread and then move on, right? So now let's execute the lifecycle thread. Yeah. So initially my child thread is in a state of new, and then the the child thread will be runnable, basically this piece executed basically. Then the thread running is main, this section is executed, and then the inside child thread is runnable again. So inside also it's a runnable because it's still running it, right? So we don't have a termination there, so it's still running now. So for this, that before completing the child thread, the main thread has it's finished its execution, so that it's still in a runnable state. But how do you make your main thread to wait that the child thread can finish its completion and then main thread will run by using a join method. So it's same thing, like it will get an interrupt exception as a checked exception. You have to catch this or throw this to throws to handle the exception. So once we make the child thread to join, it has to be completed its execution. Then only the main thread will execute. Let's see that whether this will work in the same way. Yeah. So now the child thread state is in new, right? The first thing this is got executed. Then it waited for 1000 milliseconds, and then 1 second. The inside child thread. So the inside child thread is runnable, and then after this, so because it's finished its execution, so that's why the status has changed to terminated, and then the finally the main thread is completed its execution, right? So this is a simple thing, like how it will went to new, runnable, and terminated. Blocked and waiting we will see in the next sections of this later. No. Yeah, so you might have seen this, right? So important methods in the thread class: start, run, sleep, join, and wait. Wait has a timed waiting as well. Join also, you can join this threads for the timed waiting, and then it will complete it in later stages. So starts the execution of a thread. So it will not start the execution, basically it will make the thread to be runnable. And then the run is a method which is you need to write your entire code, whatever the statements needs to be executed when the thread running, so you have to complete it in the run method. It's a no org constructor, no org method. Sleep is that mandatory that you have a one argument which is a long milliseconds, and it waits for that much time. It's a whole, the thread will pass the execution for the time whatever we have mentioned in the sleep, and then we'll have to continue it. Join is other threads will have to wait. It's not like that. So whichever the wherever you join this thread from the thread 1, you say that thread 2 has to be joined in this one. So first the thread 2 will complete, and then the thread 1 will complete, like that. So wait is just waiting for your resources. You will wait for some time, or like you will wait unless the other thread needs to be finished and all of these things, right? So this is the way. Then important question and answers in this one. So does a Java application has how many threads? Initially one, that's a main thread, and main thread also will initialize the other demo other threads, which are called like finalizer and garbage collector. All of these threads, they will finish their own. How to find the name of the thread? So you can use the thread.get name or thread object.get name. Can you change the name of the main thread? Yes, of course, you can use with the set name. What happens if you call the run method instead of a start? So you have a child object, right? So what happens if you create if you call the, or if you invoke a run method instead of a start? So then this will not execute as is. Let's come to the same example again here. So now we have started the thread, and the current thread name is the child thread, right? Let's execute again the first thread, and then you will see. Yeah. So we have a customized name and the child thread is name. So then we will say that it's a run. Now the thread will not start and the current thread will still be a main thread, and the current thread name in the child will be a main. So for every child run we will say, okay, to make it complete differentiation. So if we run the method, I mean if you call the run method, so if you see the current thread, the child, it's a run main, and thread is running, current thread is a customized name. So that means here this one, so it though you did not join this or you did not start the thread, it will complete in a normal like method call, and it will complete as is a sequential operations of it, right? This is the basics of the threads, and thank you. See you in a later.